Hello and welcome to a new chapter of UAS3 and SDT340 training. In this chapter we will talk about open-end measurements and alarm notifications. So let's just make a small introduction to open-end measurement. As you know, all the measurements need to be set in UAS3 or set in SDT340 in a free mode, and the acquisition time is defined, whether it will be 5 seconds, 7, 10 seconds or 10 minutes, which is maximum measurement time in SDT340 at 32 kilosamples per second. So there are still situations when we cannot define nicely the acquisition time. Let's take as an example steam traps. If we set the time of 20-30 seconds, it's not necessarily enough because it's a random operation on demand, and a purging process can be after 1 minute, 1.5 minutes. On the contrary, if we set a time, we use the luxury of the long acquisition time in SDT340, and we set it to 5, 6, or 7 minutes, it may happen that you can hear and record the cycle after 20-30 seconds, but then you have to wait for a long time to collect the measurement and to save it. Of course, that's not the only example. There can be examples in variable operating conditions, in the process changes. Sometimes we want to catch something during the process, which may be completely out of our control, on a very low speed bearings, on a certain movement, which are not complete rotation or just part, linear movement. There will be a lot of situations where this can become very handy. If we have an open-end measurement, then I can set up the measurement at the maximum time and stop it at any moment. Open-end means doesn't mean never-ending measurement, of course, because there is a maximum acquisition time as a capability of SDT340. But by open-end, we mean that you can stop the measurement at any moment between initiation and the maximum acquisition time. That basically means that if I want to inspect a steam trap and I want to record the data and have the data in my UAS3, I will select the open-end measurement, start measuring, and once I collect the interesting part of data, the data I was looking for, I can stop the measurement and it will be saved. So that means I will not waste any more time waiting for something to happen because it already happened, and I have everything I need. In some other cases, if I want to record my inspection of the electrical cabinet with the airborne sensor scanning the cabinet door, it's very difficult to set up the acquisition time because every technician will do it at a different pace. So sometimes we say, okay, record nothing, and if you find a problem, if you find an indication, stop there and make a recording. But it can be much easier if we set up the open-end measurement and let's say to 5-minute time, 2-minute time, and then we just scan and stop the sensor at the point, continue measuring, and once we inspect the whole cabinet, just stop the measurement and you have entire measurement saved of the entire cabinet door. So you will see during your use that there are many applications where this can become very handy. But of course, it's very important not to get carried away, because condition monitoring is based on a measurement that can be compared. So we don't want to look at a trend that contains measurement of 5 seconds, 25 seconds, 2 minutes, then again 7 seconds, because those are not perfectly comparable data. So the foundation of our condition monitoring practice must be the defined acquisition time, but in some additional cases where it can be very helpful, we can add open-end measurement and have a longer recording just in order to catch some potential problems and some variations. So let's go into a small database that we prepared. We used this database in one of the previous chapters. So I have my process 1 here. I have my extraction fund number 1. And as you can see on a non-drive end bearing, I have several measurements defined. I have vibration measurement and ultrasound measurement. Here you can see what you learned in the previous chapter, that I'm not following the interval properly. Data is not collected, so not a good thing, definitely. But right now I can deactivate this indicator, so because we'll not need it in this chapter. So as you can see here in my settings, my measurement is defined as 5 seconds. What you can see here just next to it is open-end measurement. So I can define this measurement to be open-end by default. That's one of the options. For that purpose, let's open a new measurement. Add the new measurement setting. I will use the same sensor. I will use 32 kilosamples per second, and I will click open-end. My interval, let's keep it the same, 1 month. So now it's an open-end measurement. It's 32 kilosamples per second. What you can see here is showing you the maximum time. That's not necessarily the time that you will use for that recording, but that's the maximum time you have. Then I will simply save it. I can also edit to my work order, and it's going to be let's just put a new one. I will call it open-end. It can be in the same work order, of course. There's no any obstacles to do that. So now let's upload this to SDT340 so we can collect the measurement. Okay, exporting last measurements. And done. Okay, now let's move here. Activate the screen so you can see it. Okay. So now I can go in my work orders, and what happens in my work order with open-end is once it's open, it shows me that my maximum acquisition time is 600 seconds. So I will increase my amplification. I'm ready to take the measurement and start. So now the maximum time is 600 seconds. I'm collecting the data. Now I'm at the 1% of the maximum time. And let's say that now something interesting happens. And we continue measuring. So your only limitation is 600 seconds in this case. But I can stop this measurement at any time. So I press enter, stop the measurement. I need to confirm. Confirmed. And I will save it. So the measurement will now be saved. You can see everything just like any other time. You can see all of the indicators, all 4 of them. In the upper right corner, you see what was the duration of your measurement. It was 41 seconds. And I will simply save my measurement just like any other measurement. Next time I can do the measurement of 10 seconds or 550 seconds. It really doesn't matter because I set up the open-end measurement. Now this is the way you will do the open-end measurement if you define it as your default setting in your UAS3. But we can have a different scenario. We can have a scenario that I did not define that in my UAS3. I'm collecting my data based on a fixed acquisition time, 5, 7, or 10 seconds, whatever. But I may find something very interesting. In that case, I can go to free mode. I will select my sensor in the free mode and press F3 for the small wheel settings. And here you have a new field added, which defines open-end measurement. So in this particular case, open-end measurement is enabled. I can disable it and then go down and set up the time the way I want. Or I can simply say enabled. I want this measurement to be open-end. just to make sure, I will choose 256 kilo samples here. That means I have the same sampling rate, the same sensor, the same position in the tree structure as my predefined measurement, which was, if I'm not mistaken, 5 seconds. So those are my settings. I'm happy. The maximum time is 75 seconds. The maximum time, as you know, drops with the sampling rate. So this is the maximum sampling rate and the minimum acquisition time, 75 seconds as a limit. And I will start my measurement now. So my limit is 75 seconds. I normally take 5 seconds. Now I will take the measurement for whatever reason that there might be, any way I want. So I will wait a little bit more. And I will stop the measurement now. Yes, I collected the data that I was looking for. And I will save the measurement. And now the question, the 340 asked me, where do you want to save it? So I will save it in fan group, extraction fan 1, motor, non-drive end bearing. And the measurement is saved. It's an alarm, by the way. That's the next topic we will discuss. And I don't want to add message. That's also the next thing we will discuss. We'll escape this, and that's it. Okay, now let's download this to UAS3. And let's see what happened. Okay, so first of all, this is the measurement I had as a default. If you remember, the setting was open end. So this is something I set in my set as open end in my UAS3, and you can see this measurement was taken, and the duration of the measurement was 41 seconds. But after that, we went to a free mode, and we used 256. In 256 kilo samples, I have defined a measurement of 5 seconds. But at this point, for some reason, I wanted to take a longer measurement. And that measurement is saved, of course, in the same position, but you can see the time is, in this case, duration of the measurement is 20 seconds. I'm sure you remember and you are using this feature, but now you can exclude this from the static trend graph. So the measurement is, of course, still here. You can see the measurement, you can see the time waveform, you can see the spectrum, but it's not in a trend anymore, which is not a bad idea, because I don't want to compare 5 seconds with 20 seconds, especially if I did this measurement under some really specific conditions. So open-end measurement can be highly useful in many cases. For instance, as you can see here, steam traps. So I have a battery 1, I have steam trap number 1. Of course, I will set up my measurement. I will set up the measurement in a way, in this case RS2T. Normally I would never use RS2T, but a needle. And of course I need to set up the interval, let's say 3 months, which would do the job. And I will save. Now my measurement here, as you can see, is open end with a maximum of 10 minutes. Once I place my sensor on a steam trap, I will wait until I get the information I need. I will stop my measurement, and that's it. You can have a similar situation on a valve, let's say in hydraulic presses, where you will follow the process, how it works, and collect data, and then you will see the opening and closing. It can be used on a turret, for instance, in the steel mills, where the rotation is not complete but only partial. So there will be a lot of different applications when you can use this. Open end applies to all sensors, and open end can be set in a free mode in SDT340 and then saved at a certain position, or it can be predefined as a measurement in your UAS3 tree structure, exactly as we did here in this case. So It's an excellent feature that can save you a lot of time. It can open new possibilities during your measurement, where you can monitor the entire process, even though you don't know what will happen when. So I strongly suggest to use it. The next feature is indication of the alarms in SDT340. You have seen it a little bit earlier when I was doing the measurement, but let's just see how to use it. So you can see in my software I set up the alarm levels. For instance, on RS2T focus, it's 5 seconds measurement, and here below I can see the alarms. I have a node alarm in this case, and node alarm is at RMS, no, max RMS 5, 10, and 15 dB. Okay, so now let's go here into our 340. And you can see I will collect the data. Okay, now the data is being collected, and I hope with this mimic of the signal I will trigger the alarm. Okay, what you see on the screen is now that the alarm has been triggered. You see what indicator was alarm set on. It was set on max RMS. The current status is danger. There is a value of the current measurement, but also there are all three values of the alarm. So what is the alert, warning, and danger level? This can be quite useful information, because if I am in an alert level and my warning is at 10 and my measurement is 9.9, it's quite important to be able to see it, to understand that yes, you are officially in alert, but you are basically 0.1 away from warning, so you can have a better feeling about that, especially if the gap between three levels of alarm is high. Now, when the alarm is triggered, you save your measurement, you acknowledge it, and then you continue with your work. Now, if you want to go back during your inspection to see at which points the alarm was triggered, because maybe you would like to remeasure again, or there was a lubrication and now you want to remeasure it again, you can scroll through your work orders, and there will be an icon showing that alarm has been triggered on this particular point. So notification for that part is here as well. Or you can go through the tree structure, and you can see on database root video manual March, it says it's an alarm. Now it's an alarm because of the fan group. The fan group is an alarm because of the motor on extraction fan number 1. And here it is, non-drive end bearing. If I press right arrow one more time, I can see that it's an alarm because of the ultrasound measurement with RS2T 256 kilosamples. So both for people working in the field and people working in the software, it will give you equally timely and proper information. Now we can download this data back to UAS3. And once download, I will see the alarms. We triggered alarm on RS2T 256. Okay, so here we are. Here is the measurement that we did right now. It's danger. The status is danger because of max RMS. So you have seen in previous chapter that now the font color of the indicator is in the color of the alarm, so you can immediately know where does it come from. It's quite useful for the people in the field to see if the alarm is triggered or not. Maybe some action needs to be taken immediately. So use this feature, and I hope it will help you in your daily work. Thanks a lot.